Hello and welcome to SudoKanard. We're here to solve this German whisper Sudoku by Indian author Akash Doulani, and actually I published a solving video of this very puzzle a few hours ago, but Akash pointed out the fact that my argument was incorrect. At some point I made a logical leap that led to the right solution, but with obviously a real mistake in my reasoning, so I decided to redeem myself by doing a new solve, hopefully a correct one this time. So the special rule is that whenever you have two cells connected by a green line, then the corresponding digits must have a difference of at least 5. So they could be 1 and 6, they could be 2 and 9, but 5 would go with nothing, and 6 can only go with 1, 4 can only be with 9, and so on. So let's start with this row. So here all small digits are here, so those digits must be big digits from 6, 7, 8, 9, but we can see that 6 doesn't work. 6 would have to be surrounded by 1 and 1. So that's not possible. And actually 7 doesn't work because 7 must be surrounded by 1 and 2, and you can see that none of them is available here. So this is actually 8 or 9. It's surrounded by 2 small digits, so here 1 and 2 are not available. This is 3 or 4. 3 is not available here. Here it can't be a 6 for the same reason, but this time 7 seems to be a possibility. It's surrounded by 1, 3, or 4 here because of that. And, well, I will pencil mark all 4 options for this digit. Here I have all 4 small digits as well. So this is also from 7, 8, 9. And this also from 7, 8, 9. And those are surrounded by 2 small digits. And here that's interesting. We have 2, 1, and 4. So this can only be 3 as a small digit. And 7 doesn't work in here. And this is now from 1, 2, and 4 as well. And here we have an 8, 9 pair, which is sort of interesting, because in this column we need 5, 7, 8, and 9, so this can only be 5 or 7. Here this must also be surrounded by 2 small digits. There's a 4 there, so this is from 1, 2, 3. There's a 2 and a 3 there, so this must be from 1 and 4. So in my former video, I said that it had to be a 1, which was wrong. So it turned out to be correct in the end, but there is absolutely no reason at this point of the solve to exclude 4 as a possibility. Now here, because we have 1, 2, 3, 4, this must be a big digit. So this must be a small digit, and it can't be a 3, and it can't be a 4, because 4 would have to be surrounded by 9 and 9. So this is 1 or 2, surrounded by big digits. Well, at this point, all of them seem to be real options. So let's do that. So what about this? Well, here, 7, 8, 9 here, and this can't be a 6 for the reason I mentioned earlier. 6 would have to be surrounded by 1 and 1. So those 2 are small digits, and they have to be 1 and 2 because 3 and 4 are already taken. Here we have 5 and 6. 1 or 2 is surrounded by 2 big digits, and because of that, this is from 7, 9. And this can be any one of the 4 big digits. Here, because of those, it has to be a 9, so that's a 7 after all. And here this is from 6, 7, 8. And this 9 now removes this candidate, and now 4 is not valid. 4 can only be next to the 9 along such a yellow line. And now we can see we have a 1, 2, 3 triple in here. So only those 3 digits can go into those 3 cells, so they must fit these 3 cells exactly. And we can see that 3 is in one of those 2 cells. So that 7 here is not an option. 7 would be surrounded by 1 and 2, and 3 would go nowhere in this column. So that's an 8. That's not 8. That's a 9. That here is not a 9. And now this 9 makes this an 8. So this is not 8. And this can't be 4 anymore. This can't be 8. And that's not 8 either. In this row, I get a 6-7 pair. Now there's something really nice here, which is a Y-wing. Namely, what is happening here is that we have 3 digits in this, well, on this strange triangle, and whatever this is, if this is a 6, then this is a 5, and if this is a 7, then this is a 5. So I know that one of those two cells is a 5, and therefore this cell here can't be a 5. So the only place for a 5 on this column is finally here. And this is 7 or 9. And then by the rules of Sudoku, I get a 5 in here. All right, so where do we go now? So I have a 1-2 pair here. So the remaining digits here are 4, 6, 7, 9. And because of that, this is 4 or 6. And because of that, this is 4, 6, or 7. Okay, something else of interest here. Of course, I have to consider what's happening here. But now I'm seeing here an X-wing. So there is some standard Sudoku logic here, which is neat. So what is happening? There is a 6 in one of those two cells. There is a 6 in one of those two cells. So in those two columns, we have located 2 instances of 6. I don't know at this point whether it's on this diagonal or on this diagonal, but I have 2 instances of 6 in 2 columns, so 6 can't go anywhere else on those columns. So, for example, this can't be a 6 anymore. Well, that doesn't seem to matter a lot at this point. So, well, I think it's time to address this. In this column, I still need to place 1, 2, 4, and 9. So this can't be a 4, because 4 must be surrounded by 9 and 9. That's not a 4. And actually, that's not a 2 either, because 2 would need here a digit 6, 7, 8, or 9, and none of them is available. So this is actually only 1 or 2. So if this is a 1, then this is a 6. And something interesting is that if this is a 9, then this is a 7, and this becomes a 1. Because 4 doesn't go with 7. So what I'm saying is that if 1 is here, well, this is a 1. But if that's not a 1, that's a 9. In which case, what was I thinking? Yes. If this is not a 1, then that is a 1. So 1 is one of 2 places here, and this is never a 1. Now there's something really interesting about both options here. If this is a 2, then this is a 1 and this is a 2. And if this is a 3, then this has to be a 9, and this has to be a 1, and this has to be a 2. So whatever the value of this is always a 2. And this can't be a 6 anymore. That's a 7. That's not a 2. That's not a 7. I get a 4, 6 pair in here, so that's not a 6. And actually, that's not a 9 either. I had missed this. So that's a 7 and that's a 9. And now this 2 makes this a 1. So that's not a 1 anymore. And then, is that it for the time being? I'm the king of overlooking nice deductions, but I don't think that's the case at this point. All right, so where do we go from here? So if this is a 1, then this has to be a 6. I really think I'm missing something. I just can't see what it would be, so let's move on. So if this is a 1, then this is a 6, and if this is a 6, then this is a small digit, and it's not a 4, and it's not a 1, because I already explained that 1 has to be here or there. So in this case, that's a 2 or a 3. I'm certain that I have the feeling I am forgetting something. All right, whatever. So what is the next step? Yes, it's the same, I think it's the same kind of reasoning that I did here. But with 2 or 3 or with 1 and 9, here, if this is a 2, then this is a 1. And if this is a 3, then this is a 9, this is a 1, this is a 2, and this is a 1. So it's the same kind of logic. Whatever the value of this has to be a 1, and this has to be a 2. Now, knowing this, in this column, I still need 1, 4, and 9. So this is 1 or 4. And it could be either value here. Here I need 6, 8, or 9. This column needs 4, 5, and 6. This is 4 or 5. This is 4, 5, or 6. I feel I'm missing something that would lead to a real breakthrough at this point. Perhaps I should note that this row still needs 1, 2, 3, 4, 5. So this is from 3, 4, 5. 1, 4, 5 to 2, 3, 4. That doesn't seem to be it. I feel like I'm really missing something very simple at this point. I just can't see what it would be. Oh, perhaps the value of this. If this is a 1, then this has to be 6 or 8. 7 and 9 are not available. If this is a 9, then this is a small digit, and because I already know that 1 is either here or there, it won't ever be a 1. So only 4 is available. So 9 goes with a 4 here. 1. So 9 goes with a 4, 1 goes with a 4 here. So that 4 is in one of two places, and this is never a 4. Which means I get a 5, 6 pair here, and this is never a 6. So 9-4 here or 9-4 there. Oh, this is what I've been missing. This 7 makes this a 9 and this a 7. Sorry about that. So this can only be a 3 now and a 1 there, a 2 now. And this is the 9, so that's a 3, and that's the 4. And that's the 1, that's the 4. This is the easy deduction I've been missing. Right, that's a 5, and that's a 4. So now this should be easier. This 5 makes this a 6. That's a 5. That's a 4 now. What did I do? And this 6 now makes this a 7. That's a 6. Here this can only be a 7. This row needs 6 and 8, so that's a 6. That's 8. That's 6. And this is 5. Here I need 8 and 9. This 3 here makes this a 1. That's a 3. That's a 1. And this here is an 8. This here is a 3. Here I need 2, 4, and 5. This 1 makes this a 5, so that's a 4. That's a 2. That's a 5. That's a 3. 1 and 2. Here I need a 5. That's here, and that's a 3. 2 on this row must be here. That's not a 6, so that's 8. That's 6. 9 and 8. 9 and 8. 7 here, 4 there. 9 and 6, and that's correct. And I think this time the logic was good. I certainly missed something at one point, but I finally made it. I redeemed myself and offered a proper solve of this puzzle that was really not that easy by Akash Doulani. But I really like the fact that when you explore two possibilities, they lead after very few steps to the same answer at some point. This is called commonalities, I think, in other pencil puzzles like Heyawaki or stuff like that. Thanks for watching this video, and see you soon on SudoKanard.